Hey guys, just a quick video on inequalities. Like this is really a throwback to grade 9, not even grade 12 because we're not graphing them, we're not doing that sort of thing. So just gonna whip through some things about inequalities. It should be a pretty fast assignment for you, but don't forget that we have a test on Tuesday. So just want to keep that in mind. Okay, set notation. This is what Rahat likes. This is what I like, interval notation. We usually close these up with our fancy oh, I didn't do my fancy brackets right. That's why I don't like it. So this is just saying x is less than a number. So x is all values less than whatever that number is. But because it doesn't have the equal to sign, it would be a round bracket for us. And then this one, x is less than or equal to, so we'd switch to that square bracket. X is an interval between two numbers. That would be round brackets on either side because we don't have the equal sign. Those would change to square brackets if we did have the equal to sign. And then again, this would be x is greater than or equal to a number. So it would be the number headed towards infinity, inclusive because it has the square brackets. Again, missing that equal sign, so it's a round bracket. This is all stuff you know, probably could do in your sleep. So we're just going to go through and, oh, we are kind of graphing. We're putting these on number lines. So if I want to do this to set notation, I put my variable in the middle, my lower limit on the left-hand side, so low left, and then my upper on the right-hand side. This one is inclusive of it. All my arrows point to the left. So it's inclusive, so I'll have the equal to sign. This one isn't, so it will just be x is less than 3. And if I were to put this on a number line, I'm just going to grab a ruler. Maybe I'll even grab a black pen. So I'm going to put my number line on here. I know this is a really small place to write this. So 0, 1, 2, 3, they're not very even. -1, -2, -3, -4, -5. So we know that the boundary is in between them, that our values are in between. So I'm going to have an open circle at 3 because it doesn't include 3. I'm going to have a closed circle at 5, and I'm going to have a line that connects those two endpoints. So that, and I used green because I thought it would stand out, but you get the idea. Open circle at 3, closed circle at 5. The line connects both of them. If you look, okay, maybe I'll do them in order just so I don't mess it up. So this is saying x is greater than or equal to 4. So 4 is my lowest, and it's inclusive of it because it has the equal to sign, and it's headed towards positive infinity. Round brackets around the positive infinity. Okay, here I go again with my line. And if you guys need to pause the video to keep up, that's cool. So really what I have here is, I'm going to put 1, 2, 3, 4, 5, 6. I'll put some numbers on there. Okay, so we're starting at 4 and we're headed to infinity. So I have a closed circle at 4 because it's inclusive of it. And again, the pink's not even really showing up. And I'm headed towards infinity. So I'm just going to have that arrow pointing to the right. All right, so now we're looking at just this number line. So inclusive of 4, and that's the arrow, like that's the part. So this is the same as this one. So exact same thing. So we're going to have 4 headed to infinity, and we're going to have x. So we're defining the variable there. We're talking about the x. So x is greater than or equal to 4, xer. So we're saying it can be any number. Really, the domain statement is just this right here. I got to change that up. We got to wild and crazy. Okay, so there's our unison bracket. We've seen that a million times before. Maybe let's do the number line first. We got 0 in the middle. We have 1, 2, -1, -2, -3. It's going to take me all day to do this. All right, so it says, okay, I'm going to try to grab a red this time. Maybe it will show up. It's inclusive. It's inclusive of 2. Oh, so this is everything. This is infinite, because I thought this one said -2. So this is -infinity to +2 inclusive, in unison with 2 inclusive again to +infinity. So it is every value on the line. So we can write that in set notation. We can just say XER. So we could say X, we're defining the variable, and X is any element of the real numbers. Okay. So really that's grade 9, like putting it on a number line, that's grade 9. Okay, so super easy. Determine which of the following numbers are inside the interval -5 to +3. So really, it's that graph right there. So x equals -6. X equals -6 would be out here somewhere. So this one's not in the interval. That one's not in the interval. -5, that one is right on the bubble, and it's inclusive of -5, so this one is included. X equals +1, yep, that's somewhere on my line, so that's included. X equals 3. So it is an endpoint, but it's an open circle, so it does not include that point. And x equals 4, that would be somewhere out here, so that would also be a no. So yeah, you're just defining, does this variable fit on that number line? Sometimes it's easy to see as a number line. This unit is probably one of the more difficult units, but this first lesson just is like, it's like welcome to grade 9 again. Okay, so the first thing I'm going to do is I have to isolate the variable on one side. So I have x's on both sides. I'm going to bring the x to this side so that I'm subtracting x from both sides. So I'm going to have 1 is less than 5x minus 4. I want to get x by itself. So add 4 to both sides. So 5 is less than 5x. Divide by 5, divide by 5, x is greater. So I always start, if you're unsure how to read it, sorry, that was a very flouncy greater than sign. So I always start at the variable, no matter what side it's on. So x is greater than, because the alligator is eating the x is greater than 1. Okay, when you divide by a positive coefficient, the inequality doesn't flip. If we had divided by a negative coefficient, so let me do this question again, but differently. Okay, so this time I'm going to bring the 6x to this side. So I'm going to minus 6x minus 6x. So I have 1 plus, 1 subtract 5x is less than -4. Minus 1 from both sides, so I have -5x is less than -5. This time I'm dividing by a -5 as a coefficient. So when you divide by a negative, it flips your inequality around. And so this is the exact same statement. X is greater than 1. So if you're dividing by a negative, just know that you have to flip your inequality. So negative, the inequality switches directions. If it's a positive that you're dividing by, the inequality stays put. So that's that. All right, so here we go. Solve the inequality of x squared minus 4x minus 12. I'm having a hard time thinking. All right, so I'm going to go ahead and factor that. So I'm going to have x minus 6. X plus 2 is less than 0. Now, if this were an equal to sign, super easy to do. right? You set both factors equal to 0, and you're going to be doing the exact same thing. It's not really any different here. So what we're going to do is, for a moment, we're just going to solve these out because these are going to be our endpoints. So x is equal to 6, x is equal to -2. We call these boundaries. So if we were to do a number line, we know we've got 0, -1, -2, 1, 2, 3. I'll put a 7 on there just to make myself feel better. So there's my number line. And what I know is that because it doesn't have the equal to sign, both of my boundaries will be open circles. Now the question is are the test points, where does it work? Does it work inside or does it work on the outside? So I'm going to pick a test point. I'm going to say when x is equal to 0. So if I were to substitute that into the original equation, x squared minus 4x minus 12 is less than 0. So we're going to have 0 minus 12 is less than 0. So -12 is less than 0. That is true. And 0 falls in between the points. So we're going to connect these. These are going to be the true statement. Now, if you want to double check and you want to see if a point works, just to double check your math, you can always do a test point. Let's go outside. Let's go 7. So we would have 7 squared minus 4 times 7 minus 12 is less than 0. So 49 minus 28 minus 12 equals 0. And so if I do that, that'll be 40. So it would be 9 is less than 0, and that is false. So we only want to connect the points or put the connectors where it is true. So this one wouldn't work. So we know that this point doesn't work in this inequality. So, and we're going to do it in set notation. So we've given it on the number line. Now we're going to do it in set notation. So -2, lower limit on the left, variable in the middle, upper limit on the right-hand side. All the arrows point to the left. All my inequality signs point to the left. No equal to sign because there wasn't one in the equation. Define the variable and then say it can be any number in between that. Put some fancy brackets on it and you are done. So there it is as a number line as a solution, and there it is in set notation. Okay, so now we're going to do this one. We're going to do the same thing, but this one's given in factored form, so this is going to be nice and easy. I know I've got my ruler around here somewhere. So I know that my boundary points are going to be x equals 1, x equals -3, and x equals 2. So those are my boundaries. So when I do my number line, okay, so because this is the equal to sign, that means it's a closed circle at all of these. So I've got a closed circle here, a closed circle here, and a closed circle here. So now I've kind of got like 3 x-intercepts, and I just have to figure out what's happening. Okay, so we're going to do sign analysis. And this one we actually substituted in, figured out what the test point was, but we're going to do sign analysis from this because it's equal to 0, and it makes it a little bit easier. So I'm going to pick the test point x equals 0. Oh, I guess that one will be really easy to do. But this is what I mean by sign analysis. We're just looking whether or not they're positive, negative. If I put a 0 into here, the first bracket is going to be negative, because it'd be 0 minus 1, so that'd be negative 1. If I put a 0 into the second bracket, it would be positive. And if I put a 0 into the third bracket, it would be negative. And so if we get this is going to be a negative times a positive is a negative. Negative times a negative is a positive. So it's going to be a positive number. So like 3 is greater than or equal to 0. This is false. So I know that this in between these 2 points, that doesn't work. Okay. So now I've got to be strategic. So what we know is that this in here is not connected. So now I got to look at negative 4. And I always like to pick nice numbers, but you get what you get sometimes. So negative 4. So again, I'm doing sign analysis. I'm putting a negative 4 in for the x, so my first bracket will be negative. If I put a negative 4 in here, it will be negative. If I put a negative 4 in here, it will be negative. So we would end up with a negative answer is greater than or equal to 0. Geez Louise. Guys, I didn't do my math right here. This isn't false. 3 is greater than 0. That is true. It's a good thing I wrote an erasable pen. Negative, so negative 2 is less than 0. This one's false. Okay, so let me add my E. What we know now is that when I do my math right, these 2 points are connected. This is wrong. So now I'm going to pick a point outside. I'm going to do a test point. Maybe I'll pick a point in between. I'll do a test point. So again, this is why sign analysis is helpful. I don't really have to worry about decimals or anything. I'm just substituting 1.5 in here. It's like the ish math. If I put 1.5 in here, this will be positive. If I put 1.5 in here, it will be positive. If I put 1.5 in there, it's going to be negative. So we'd get a negative answer is greater than or equal to 0, and that is false. And so we know that they can't be connected here, so I'm going to try 3 next. So if I put a 3 in that first bracket, it'll be positive. Put a 3 there, it'll be positive. If I put a 3 there, it'll be positive. So we're going to have an answer that's positive greater than 0, and we know that that is true. So that means that this goes on forever out here. So that's kind of what my thing looks like. It's a little bit different, and that's okay. So now we got to do our set notation for this one. So our set notation, again, I just got to leave myself some room here. So we're going to define the variable. So x is what we're dealing with. We're going to start with our lowest limit. So our lowest limit is negative 3. X is in the middle, and that goes up to 1. We know that our inequality has an equal to sign. So it always points to the left. And that's in unison with, we've got this other section. So lower limit on the left. But really what we're saying is x can be any value greater than 2. So x can be greater than or equal to 2. We're going to say x is any element of the real numbers, so it can be decimal points and stuff inside of there. And then we close it with a fancy bracket. I was looking at that. That's not a line, that's a 1. So I think that's good. That's it. It's just writing your things as interval notations or set notations. You got to get comfortable reading and doing both of them. But that's it for this lesson. Good luck, and I will see you on Monday.